In today's video, we are going to discuss about symmetric, asymmetric keys and digital certificates, which are the foundation of distributed systems security. So suppose we have Alice and Bob. Alice is the wife, Bob is the husband. So Alice sends a message to Bob, "Can you send me your credit card number?" And Bob, being an obedient husband, will tell her the credit card number. And all this communication is, let's suppose, going over internet. And now let's suppose there is a rat listening to this communication. Then he will be able to see what Alice is asking to Bob, and he will also see that the Bob has sent a credit card number, which is this, and he can use that credit card information for himself. And now, because of this, Alice will be very angry and Bob will also be very angry. So if Alice and Bob don't want any rat, what they will do? They will actually use some encrypted communication mechanism. So let's suppose there is a key K. So Alice and Bob knows that key. Now Alice will actually send this message by encrypting it with this key, with some random string or something that even if the rat sees, he won't be able to decode it. And then Bob will take this message and pass it through a decryption algorithm using the key to get the actual message. And the same way, when Bob will send the message back to Alice, he will use the same key to encrypt the message. And then when Alice will receive the message from Bob, she will use the same key to decrypt the message. And in that case, they will be able to communicate this information securely. So this key K is called symmetric key because it is the same key which is used for both encrypting the message and decrypting the message. It is also sometimes called session key because whenever in a distributed system two parties communicate and they create a secure session, then they actually use this key to actually encrypt and decrypt the messages, and that's why it is also called a session key. So in order to exchange the symmetric key, we actually use another type of keys which we called public-private key pair. So let's suppose that Alice has a public-private key pair which we are calling pub of A, which is the public key, and pri of A, which is the private key. Similarly, Bob also has a public-private key pair. The public key of Bob is pub B and the private key of Bob is pri B. So as far as this private key is concerned, only Alice knows Alice private key. Similarly, only Bob knows Bob private key. Now Alice and Bob, they can publish their public keys to each other. So now Bob will know the public key of Alice and Alice will know the public key of Bob. There are 4 different things that can be done with this public-private key pair. So the first thing is encrypt a message. The second thing is decrypt a message. The third thing is sign a message. And then the fourth thing is verify the message. So this encrypt and decrypt is a pair and sign and verification is a pair. In order to encrypt a message using a public-private key pair, you need the public part to encrypt a message. The decryption only happens with the private key. The signing process is only done with the private key, and the verification can only be done by the public key. So now let's discuss them in detail. The encryption is only done using the public key. So now if Alice needs to send a message to Bob, Alice will use Bob public key to encrypt a message. And now this encrypted message can only be decrypted using the private key of Bob. And since only Bob knows his private key, so no one else except Bob can actually decrypt that message. Similarly, if Bob needs to send a message to Alice, Bob will use public key of Alice to encrypt the message and send that encrypted message to Alice, and then Alice will use her private key to actually decrypt it. While they are communicating, if there is a hacker or a rat which is listening to those messages, he will not be able to decrypt those messages because he does not have the private keys. So now usually how the session keys or the symmetric keys are exchanged is that there is a handshake and one of the party actually decide a key or generate a session key, and then it uses the other's party public key to encrypt that key and send it to the other party. For example, the Alice and Bob can actually do some handshake and then Alice can decide some session key K, and then she can actually use public key of Bob to actually encrypt that key and send it to Bob. And since Bob is the only one who can decrypt that message using his private key, he will be able to decrypt it, and then he will know what is the session key which Alice wants him to use while communicating over the public network. So that's how the public and private keys are used to actually exchange session keys. Public-private key pair is called asymmetric keys because we use public key to encrypt the message and then private key to decrypt it. Similarly, these public and private keys are used for signing and verification. For example, if Alice says that I am 21 years old and she signed this message with Alice's private key, the output is a digital signature, which is nothing but just a hash. And that hash she can send along with this message to Bob. And now Bob needs to validate whether this message is from Alice or not. And in that case, what he will do? He will use the public key of Alice to actually verify this message along with the hash that was sent with this message. And if the verification is successful, then it means that this message was indeed sent by Alice. These public and private keys are then used for generating digital certificates. So what is a certificate? A certificate is nothing but just a document which is signed by the private key of the sender. And so anyone who has the public key of the sender can actually validate that this is a certificate which is generated by the signing authority or the signer. So now let's go to the problem where how these public keys will be exchanged in a way that each party can actually assume that the public key that they are seeing for the other party is the right key. For example, when Alice sent his public key pub A to Bob over the network, how Bob will know that the public key that he is receiving is indeed from Alice? It's totally possible that there's a hacker in between which actually can switch the public keys. So in order to tackle this scenario, we use digital certificates. So now let's assume there's already some person, Think Software, who both Alice and Bob trust. And this Think Software also has its public key, pubTS, and private key, privateTS. And both Alice and Bob, they know public key of Think Software. So now Alice wants to send her public key to Bob. Alice will go to the Think Software and Alice will tell Think Software, can you give me a certificate that I am trustful and this is my public key that you can attach to it. She gave her public key to Think Software. Think Software, he will generate a certificate and also it has pub of A in it, in this certificate. So now Alice will keep this. Similarly, the same thing will happen for Bob as well. Bob will also get a certificate from Think Software because Think Software also knows Bob along with Bob public key. So now when these two need to exchange their keys, Alice will simply send this certificate that she got from Think Software to Bob. And similarly, Bob will send the certificate that he got from Think Software over the network to Alice. And so when Bob will receive certificate that Alice sent, so he will see in the certificate that Alice is trustful and this is the public key of Alice. Since this certificate is signed by Think Software, so he first try to validate whether this certificate is indeed signed by Think Software or not. So Bob will use the public key of Think Software to validate. And once the certificate is validated, then he will know this is the public key of A that he can use to actually send any encrypted message. And same goes the other way around as well. So in this scenario, this Think Software is called a certificate authority or CA. This certificate authority or CA is something that is already known and verified by the parties. And now let's see how this scenario is get applied for our distributed systems. Now consider a scenario where we have a client browser, for example Chrome, and the Chrome browser wants to communicate with the web server, and there is some certificate authority. When you install a browser, like for example Chrome, the installation process also installs some certificates from a certificate authority as well. So now what happens is that this web server will also give a public key pub of web server to this certificate authority, and the certificate authority will actually generate a certificate which embeds that public key of the web server, and also it will say that this web server is trustful and it will send that certificate to the web server. When the client browser makes a connection, the web server actually passes that certificate to the client browser. Then it uses the public key of the certificate authority to validate whether the certificate is indeed signed by the CA or not. And if it is signed by CA, since the browser trusts CA, it will also now trust this web server, and then it will actually use the public key that is embedded in the certificate that it received from the web server to actually encrypt a message and send it to the web server. So I would really appreciate if you like my videos, and if you haven't subscribed to my channel yet, what are you waiting for? Please subscribe to my channel. There will be more videos coming. Take care and bye.